So another thing to think about when you're developing anchoring phenomena is that they should be contextualized and not generic. So on the left, we've got generic or general phenomena, like how are volcanoes formed. If you just ask kids about volcanoes in the generic, they will not be interested. But when we taught this unit in 7th grade Earth Science about 8 years ago, the teacher just happened to talk about the difference between Mount Rainier and was it Mauna Loa in Hawaii? Kilauea. And some of the kids noticed that they erupt very differently. And the teacher said, I am not sure I know why. And when that night she went home and she found out that all of the underlayment underneath the volcano, the subterranean system is really different. And she said, that's our question. Why does Mount Rainier and the Hawaiian volcanoes erupt differently? Rainier blows up explosively. The Hawaiian volcanoes just kind of leak out lava over long periods of time. Another generic phenomena is how do organisms interact in an ecosystem, and we have our very contextualized wolves in Yellowstone. Generic would be, why is homeostasis important to our body? What is it? Why is it important? We place that in the context of a high school, this could be anything, but we chose a high school cross-country runner before, during, and after a heat stroke. Sometimes when we do an anchoring event, we try to compare two cases. So we have variations of this where we have two runners, and it's same heat, index out on the same day, they run at the same speed. In fact, they could be identical twins, but one gets heat stroke, the other does not. Why is that? So here's our checklist for finding good anchoring events and an essential question. So we were trying to wrestle with the cancer thing a few months ago, and we thought the kids might be interested in a case of cancer that comes from overexposure to the sun, or more specifically in tanning booths. So we were testing this out. This young woman in her mid-20s has been using tanning booths regularly since she was in middle school. And she found a little dot on her nose, and her mom is concerned. She goes to the doctor, and it's basal cell cancer, and she has that excised. And I usually tell audiences that this hits very close to home for me, because I had that exact same cancer in the exact same spot, right where the girl does, and it was blue, and I could not figure out what it was, and I waited a little bit too long, and I had to have that surgery, which is unpleasant. But it could hit home for a lot of high school kids for studying cells. So here are the 4 criteria. So is this girl getting cancer, the process from start to finish post-surgery, is it a phenomena? Is it something that unfolds over time? Yes, because there was a time before she had this cancer. And then there was a time where something went wrong and the first cells started to go haywire. And then there's a time maybe post-surgery. So it is something that unfolds over time. It is contextualized because it is a young woman. We know her past history about going to the tanning salon. We can add more detail to that, even though she is fictional, or it's possible to use a real person if you know them and they're okay with you using their case. Does that explanation require that a lot of core science ideas get integrated together? It could if you demanded it. Because this could be explained just by talking about DNA, the screw up in the DNA. But you can also talk about how normal, healthy cells function. You can get into that, osmosis and diffusion across the cell membrane, everything that makes a cell healthy can be part of that unit. So it's conceivable that that could bring in a lot of good core science ideas. And then is it possible for students to come up with multiple different kinds of explanations? This is important to us. We do want them to have different kinds of explanations. They look a little bit different. If all of your students develop the same explanation or have models that look identical, you probably have not picked a challenging enough anchoring event. Or you probably are having them reproduce knowledge that's in a textbook, which you want to try to avoid. So I want to just stop and caution all of us. When you teach a unit like the Yellowstone unit, not every valuable science idea about ecosystems can be taught in the context of the wolves in the ecosystem. There are some other kinds of ideas important to ecosystems, like how nutrients cycle through an ecosystem that doesn't make sense in terms of the wolves. You have to teach it separately. It has to be outside the context of the anchoring event. You teach it during the unit, but it doesn't have anything to do with the wolves. That's okay. Not every unit needs an anchoring event. I'm not here as an evangelist about anchoring events. You don't have it's probably not feasible for everything that you teach to have an anchoring event. But when we say teachers need to get started on it, we help them think about working in the summer and maybe developing 2 units that have really good anchoring events. And they try those 2 out in the upcoming school year.